Lesson 1.2, Evaluate and Simplify Algebraic Expressions. In this lesson, we'll look at practice with evaluating expressions and creating a verbal model. An expression is any grouping of numbers, variables, and operators. You'll know you have an expression and not an equation because you'll be missing the equal sign. We're going to add some more definitions onto the right. A power consists of an exponent and a base. The exponent represents the number of times the base is used as a factor. For example, if we see something as simple as 5 squared, the exponent means we multiply the base by itself 2 times, 5 times 5. But with variables, it's kind of trickier to model that. For example, if we were to take a variable like m and add m together, if we take m plus m plus m, that would be 3 m's total. So we change the coefficient. But if we take m times m times m, when we're multiplying them, that would make the exponent bigger. So there's a difference when you add versus multiply where that 3 goes. Just something to be mindful of. A variable is a letter that's used to represent an unknown number. A term is any part of an expression. It's either separated by addition or subtraction. A coefficient is just simply a number that's multiplied by a variable. So a number that is multiplied by a variable. For example, if we see that 3m up above, the 3 is the coefficient. A constant is a number that does not change, so a constant would not have a variable associated with it. Keeping those definitions in mind, circle the variables, box the constants, and underline the coefficients down below. Well, if we want to circle our variables, the variables are any letters that represent our unknown numbers. We have x to the 5th is a variable, x to the 4th is a variable, x times y in that first expression. Box the constants. Well, the constant is the number that doesn't change and has no variable. In this case, our constant would be negative 100. Include the sign with it. Underlining coefficients. So coefficients technically are the numbers in front. Well, for that x to the 5th, there should be a 1 kind of as a placeholder. And x to the 4th, it's actually negative 1. And then 15 would be the constant, or the coefficient in front of xy. Let's do the same thing over on the right. I want you to pause the video, circle the variables, box the constants, and underline the coefficients. When you're ready, press play, and we'll see if we get a match. I notice that my variables are just x cubed and y squared. My constant is negative 8. And the coefficients were positive 3 and positive 1. It's always good to review our order of operations. If you know PEMDAS is that mnemonic device to remember them, parentheses and exponents, multiply and divide, but always remember multiply and divide from left to right to keep it consistent, and then add and subtract again in order from left to right. We're going to substitute in x equals negative 3 and then evaluate the expression. It says negative 4 times x squared minus 6x plus 11. If we substitute in negative 3 wherever we see x, we end up with negative 4 times negative 3 squared minus 6 times negative 3 plus 11. Thinking order of operations, we have to do the exponent before we multiply. So negative 3 squared would be negative 3 times negative 3, which is positive 9. That gives us negative 4 times positive 9. Minus 6 times negative 3, well, there's that adding the opposite rule again. There's negative 18 right there, so we're subtracting negative 18, plus 11. From here, if we multiply to combine some like terms, we have negative 4 times 9, which is negative 36. And then we have that double negative happening, minus negative 18, which actually would change that to plus. Throw in that plus 11 at the end, and we should get an answer of negative 7. I threw in another simplified down here just to give you a wide variety of ways to interpret variable or constants with exponents. It says simplify each expression. Now, most of these you can probably go through pretty quickly, but those negatives and when the parentheses are involved make quite a difference in our solution. 4 squared means 4 times 4. I think we can all safely conclude that that would equal positive 16. But if we say negative 4 squared and there isn't a parenthesis with the negative, what that means for us is that this is actually negative 1 times 4 squared. And that with order of operations would actually give us negative 16 instead of positive 16. The difference between that example and the next one, since it's negative 4 in parentheses being squared, that would indicate that we have negative 4 times negative 4. And when we multiply two negatives, we get a positive. So just some things to consider. Again, it's that attention to detail that we'll want to be mindful of. The next set has an odd exponent, 4 to the 3rd power. Well, if 4 squared is 16 and we want to multiply it by another 4, we would get 64. Negative 4 cubed, again, would be negative 1 times 4 cubed, and that would give us negative 64. Negative 4 cubed would be negative 4 times itself 3 times, and I'm going to have to make my screen a little bit smaller here to get that to fit. There we go. If we take negative 4 times itself 3 times, 3 negatives would multiply to yet again equal a negative value. So now we get negative 64 as our answer. Again, just some things to be mindful of. The last part of our video will simply have us combining like terms. You'll want to add or subtract coefficients of like terms to combine them. If we take a look at the 3 examples on the right, it says 5p squared plus p minus 2p squared. If you like to kind of group your like terms together by putting a box around them or underlining them, feel free to do so. I kind of like to do that as well. I see we have a 5p squared and then minus 2p squared. Those would be considered like terms since the variable is an exact match with the exponent. All we want to do is combine their coefficients out in front. If we have 5 and negative 2 and we want to combine them, we would get 3. That would give us 3, and then our variable stays p squared. That eliminates those 2 terms in that expression. Plus 1p, or p at the end, is not a like term with 3p squared. So there's your simplified expression. When parentheses are involved, we're going to have to include that PEMDAS as well. So for that second example, we have 3 times y plus 2 minus 4 times y minus 7. To simplify that first parenthesis, we'll apply the distributive property. 3 times y would be 3y. 3 times 2 is 6. Be careful with anything involving subtraction. Subtraction is always going to try to get us. If we have negative 4 and we distribute it in, that would be negative 4 times y, or minus 4y. But watch what happens next. If we take that negative 4 times negative 7, that actually changes the symbol to positive 28. Now if we try to combine like terms, we have 2 terms with a variable y, 3 and negative 4. Again, if we combine their coefficients out in front, 3 minus 4 would be negative 1y, or negative y, however you want to write that. And then we've got our constants of 6 and 28, and if we add those 2 together, we'll get positive 34. Now you can write that as negative y plus 34 or 34 minus y. Either order is fine since adding is commutative. In that last example down below, we have one more set of parentheses to evaluate, and again we've got that negative out in front. We'll start off with our 4p plus 5, and then we'll take that negative 2, distribute it to the p cubed, and that would give us minus 2p cubed, and then the negative 2 with the 3, and that gives us minus 6. Now there's not a lot of like terms that we're going to group here. I'll start with my variables. We have p and p cubed, so they're not like terms. I'm going to take the biggest exponent and write it first, and that has a coefficient of negative 2. The p with an exponent of 1 is the next biggest variable, so I'll keep that second. And then my constants are 5 and -6, and that would give me a final constant of -1. That would be our simplified expression. In class, we'll finish the rest of the notes on the back.